Okay, so the next doubt is a solid sphere is released from rest. So it starts from rest from the top of a curved surface as shown. Fine. Half portion of the surface is rough. This is rough. And the other half is smooth. Okay. If the sphere is released from rough side, then the maximum height attained by it on the smooth side. Okay. You see, when they say rough, what they are saying is it is pure rolling. Okay. It's going to start rolling. Okay. So whenever you have this height problem coming in, speed problem coming in, you know we have to use energy ideas. Okay. So first I'll look at this point. Let's say this is point A and this is point B. So I can say it starts with some energy. So I can say the energy conservation. The idea of what will happen is it will start with some potential energy. It will start rolling. So finally, when it reaches here, it has both kinetic energy and rotational energy. Okay. So it's a solid space. So I can say total energy at A is equal to total energy at B. Total energy at A is just the potential energy because it's not rolling, it's not moving. But the total energy at B is rotational energy. Let it be here. I'm not going to find it. It's the rolling energy, full rolling energy. Okay. Now, what will happen? It as from this point onwards, it's going to move up. Again, energy is conserved. At the highest point, what you have to understand is the object's velocity will be zero, but it'll still be rolling. You need to understand clearly. Smooth means there is no friction acting on it. Okay. So if there is no friction, there is no torque. There is force acting on. Let's take an inclined plane. Now object is moving up. Okay. So if there is no friction, the only force acting on it is gravity. Okay. And gravity always acts at its center of mass for uniform objects. Center of gravity is same here. So what happens is it cannot produce mg sin theta, mg cos theta, normal. These things cannot produce any torque. If the torque is zero, then angular acceleration is zero, which means the angular velocity will remain constant. Understand that. Only if there is friction, friction will give me some torque. So torque is not zero, alpha is not zero, so omega decreases. So slowly it will rolling correlated, then it comes down. But smooth means you have to understand it will slow down. That is, its velocity slows down, but the rotation will never change because there is no torque. I hope you understand this. Think about it. You need to understand. So if it is rough surface rolling up, its linear velocity will be zero, angular velocity will be zero. It fully comes to rest. Only potential will be there, it will roll down. But in this case, since the surface is smooth, there is no friction acting on it. So what will happen is finally, let's say I call this point C and this is some height, final height, let's say H final. At that point, it will be having potential energy plus rotational energy. It will still be rotating. Its velocity will, so it will go stop, but its rotation will still be the same because it's sliding. Hope you can understand it. Just imagine that. So it is roll, 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 stops. Stops means it's still rolling, but its velocity, center of mass velocity is decreases, and then it comes down, rolls. Okay. And that will still, energy is still conserved. So this should also be equal to, what is the final energy at C, total energy at C, because energy is always conserved. So now I can say that this mgh is equal to total energy at C. At C, it is potential energy at that point, which is mgh final plus the rotational energy, which is half I omega square. I hope this is clear. Okay. This omega square will be the same, literally the same omega we had from here. There is no difference in that. Okay. So this is half I omega square will remain the same. Now look at this. If I look at the first portion, mgh, maybe I'll write it here. So mgh is equal to total energy at B is, it has both kinetic energy and rotational energy, right? So which means it is like half, if you watch the videos, you know, I can write this as half mv square into 1 plus k square by r square. This is the total energy during rolling. Okay. So from here, I can find v or omega, and then I can use it here. Okay. So h fine, I have literally have everything here. I just need omega. Okay. Omega, I can get it from here. Look at this. So mm cancels. So h is h. We'll do it generally. It's a solid sphere. For solid sphere, the k, radius of gyration, I think you have watched the videos, you know, the radius of gyration for a solid sphere is 2 by 5 r square. Okay. So this will become 2 by 5. So maybe I'll write it here. So gh is equal to half v square 1 plus 2 by 5. So this will give me gh is equal to half v square 1 plus 2 by 5 is 7 by 5. So this is my v square. Okay. So let's take it that side. So it's 10 by 7 gh is equal to v square. But remember, I need omega. Same thing, V equal to R omega. Understand, this omega is the same omega it reaches. Omega will increase, and once it reaches here, it will have the maximum omega, and then that will remain the same because there is no torque. Torque omega maru. So here I'm going to substitute all I need. So mgh is equal to mgh final plus half I omega square. I, it's a solid sphere, so it is 2 by 5 mr square omega square. But mr square omega square is V square. I mean, this r square omega square is V square because V equal to R omega. So this term, I hope I don't want to write more. You see, this term, this V square term. Okay. So because V is R omega, so V square is R. This term I can replace as V square, but the V square is 10 by 7 GH. So instead of this V square, I'm going to remove this V square. You see, you can watch the videos, pass and see. It is 10 by 7 GH. I hope this is clear. Now that's it. I can cancel the M. It's the same mass. We can cancel the G. So what I have is H is equal to H final. 2 cancels. I have 10 by 5 into 7H. So this is 2 by 7. So it is H minus 2 by 7H is equal to H final. So this will be 5H by 7 is the H final. I hope you understand. The important thing here to realize is if the surface is smooth, there will be no torque. So angular velocity will never change. Linear velocity changes because there's a force acting. Understand the concept clearly. There is a gravitational force acting. F net is equal to ma, and the F net is against the velocity. Okay, so it will retard. Okay, F net is minus mg sine theta. So the acceleration is against the velocity. It's moving up, rolling up, but the acceleration is this side. Acceleration means linear acceleration, so linear velocity will change, but there is no torque, so no angular velocity, angular acceleration. So angular velocity will remain the constant. So the same angular velocity here will be on the top. I hope you understand this. If you want more clarity, watch the class videos from the playlist. And if you have any other doubts, you can post on the Telegram channel. So those who are new, the link of the Telegram channel in this description. Join, post your doubts, get your video solutions, watch the class videos, keep practicing. All the best.